Okay, hi everyone. This time we're going to learn about the language of set. But before that, let us first define set. Set is said to be a well-defined collection of elements or members that share a common characteristics. For example, we have the set of students. All the members of the students can be listed because it shares a common characteristics. All of them are students, all of them are entering in the same school. Example naman, for example, we have set of the first four natural numbers. When we say natural numbers, that is pertaining to the counting numbers. For example, the set of first four counting numbers. We have set A, 1, 2, 3, 4. Set A has the following elements, 1, 2, 3, 4. The set of four counting numbers. Each of these numbers are element of A. All of these are members of A. So in symbol, we have 1 is an element of A. 2 is also an element of A. This can be written in this one. For example, we're going to have 3. We are going to have 8. 8 is not members of the set. So 8 is not a member of set A. We have to use the symbol for not element or not members. So this time, so we have here. Take note, okay, observe now on how we write the set. The set is enclosed in parentheses, in braces rather. So the elements are enclosed between the two braces. Each element is separated by a comma. So a set can be specified using the rooster method. Rooster method, the elements are listed 1, 2, 3, 4. That is rooster method. One way of describing set is rooster method. The other one is set builder notation. So in rooster method we have 1, 2, 3, 4. So this is also can be written in set builder notation. In doing that, we have say 1, 2, 3, 4. These are the set of counting numbers. So in set builder notation, we have this pattern. This can be read as X is a set of all elements of S such that P sub X here is the property that elements of S may or may not satisfy. Meaning, this is the descriptor of this one. So for example, this one, we have all of this. It shares a common characteristic. Are all of them are members of integers, positive integers. So this can be, since we're going to use this method, we're going to use variable x pertaining to the set of these elements. So we have set of x is an element of, since these are all positive integers or counting numbers. So we're going to use now this one, the special symbolic name. We have z exponent positive. X is an element of positive integers such that, okay, what is now the property that S may satisfy? Okay, this 1, 2, 3, 4, all of them are less than 5. So we can write this as X is less than 5. All positive numbers that are less than 5, those are now the elements in this set. So this is now what we call set builder notation. That is the way of describing the set. This one is rooster method. The elements are listed, but this is the descriptor of this one is this one, the set builder notation. Okay. So as you can see now, or this can be written also in many ways. Pwede siyang ganito. X is an element of positive integers such that the condition is X is less than or equal to 4. This can be in words and this can be in symbol. We have x, or the element of this set is less than or equal to 4. 4, 3, 2, 1. And all of them are, we have set of all positive integers. So, for example, we're going to have this problem. By the way, before that, before I forget, let us have, for example, how are we going to write if there are the given set has as an infinite element, or the given set has many elements to be listed. To do that, we're going to use ellipse. For example, we're going to, what are the elements that are found in a set of first 100 counting numbers. So in doing that, we have set B 1, 2, 3, and after comma, place 3 dots, ellipse, up to 100. Set of all counting numbers or natural numbers from 1 up to 100. For example, we have this one. Set B, pwede siyang maisulat ng halimbawa, for example, we have what are the set of all counting numbers. So, set C, 1, 2, 3, and so on. Infinite. So, the members of set C, members of counting numbers or positive integers is infinite. It cannot be counted. It cannot be enumerated. Endless. So, by the way, the counting numbers, nagbilang 1, 2, 3, 4, those are what we call the natural numbers in mathematics. And that is also equivalent to this term, positive integers. There is no decimal, there is no fraction. So, let us now answer this activity. Example, okay, suppose we have given, okay, the following symbolic name for each set. Set of all real numbers, meaning every number in number line, positive, negative, square root, and so on. Kasi in number line, because in number line, it has infinite number. Infinite numbers. We have 0, positive, negative, and we have also between these two integers, we can have decimals. We can have fractions. So, how are we going to describe each set? Okay, these sets are written in set builder notation, as you can see. How are we going to describe this set? Letter A, we have X is an set of all X is an element of R. R here is set of all real numbers. We have now such that the condition is X must be less than 5 but more than negative 2. Meaning, the elements are between negative 2 and positive 5. Take note that real numbers, when we say real numbers, we have rational, irrational. All the numbers in number line is present. So, for example, this number line. So, we have to use now, there is 5, there is 2. This must be included because this will be served as our basis in answering this first activity. So we have 0, 1, 2, 3, 4, 5, 6, negative 1, negative 2, negative 3. So in this one, we have what are the numbers, real numbers that are less than 5. So 5, meaning 5 is not included anywhere because it is not part of the group. It must be less than 5. 4.9, pwede, and so on. So, pwedeng 4, pwedeng 3, pwedeng 2, pwedeng 1, pwedeng 0, pwedeng negative 1, negative 2. But negative 2 is not because we said that X must be less than negative, more than negative 2. Dapat siya alangkaw sa negative 2. It must be at the right side of the number line, of the number. Negative 2, pwedeng negative 2.9, kasama yan. Lahat, ano ba, 6 is more than 5, 4 is more than 2. Negative 1 is more than negative 2. lahat ng nandito ay mas mababa ng nasa kanyang right. So we have, so the numbers, possible numbers are negative 1, 0, 1, 2, 3, 4. But this is real, this is integers. So we are here, we have R for the real numbers. Therefore, we have 2.1, we have 0.1, 0.2, square root of 3 is also part of this group. It's hard for us to enumerate. So what we are going to do now, we are going to shade all the possible numbers that can be a members of this one, infinite number, infinite elements of this letter A. So we have from this point up to this one, the shaded part, all the numbers here are elements of this set. For number 2, for letter B rather, we have, let us focus now on the given, written set. The set of all x, such that x, the element of z. Z here is set of all integers. So meaning, integers, we have positive numbers, we have 0. We have negative numbers. Whole numbers, those are integers. Without fraction, without decimal, without irrational numbers. So we have this one, number line, by the way. To be clear, let us use number line. We have 0, 1, 2, 3, 4, 5, 6, negative 1, negative 2. Let us just imagine that each of these points are equidistant to each other. Okay. So we have 0, 1, 2, 3, 4, 5, 6. So as you can see here, B, x is an element of z. Z is set of all integers. What's the condition there? So we have x must be less than 6. Less than 6. Sa mababa sa 6, 6 is excluded. This one is no longer part. 7 is no longer part. All the numbers that are written here are not part of the group. So 5 is less than 6. 4 is less than 6. 3 is also less than 6. 2 is less than 6. 1 is less than 6. 0 is less than 6. But take note here that we have, it must be more than or equal to negative 2. Negative 2 is included. We have here equal. So this is 2 is still part. Negative 2, negative 1, 0, 1, 2, 3, 4, 5. So we have now, these are now the elements of this set. Okay. This set can be described by listing all the elements. It can be described in this way by shading all the possible integers that are part of the group, or by listing all the elements. So we have negative 2, negative 1, we have 0, we have 1, we have 2, we have 3, we have 4, we have 5. To check now, 5 is less than 6, 4 is less than 6, 3 is less than 6, 2 is less than 6, 1 is less than 6, 0 is less than 6, negative 1 is less than 6, negative 2 is less than 6, negative 2 is equal to negative 2. So these are now the members of the set. For example, there is no equal sign. Therefore, it must be more than negative 2. Negative 2 is no longer included. If in case there is no equal sign here. Equal or more than x. Okay, so this one, let's have now letter C. Letter C, we have set of all x as an element of the positive integers. We have z exponent plus. This one is the special name for the set of all positive integers. So we have here, what are the positive integers? Again, those are whole numbers, positive numbers, without decimal, without fraction. All whole numbers. So we have, so meaning the negative the negative numbers are not part anymore. So, because it is positive. So, do not include now negative numbers. So, we have in number line again, 7, 6, 5, 4, 3, 2, 1, 0, -1. So, what are the numbers less than 7? So, we have positive 7, 6, 5. By the way, 7 is no longer part. Kasi the element must be less than 7 integers. We have 6, we have 5, we have 4, we have 3, we have 2, and we have 1. So the possible elements are positive 1, positive 2, positive 3, 4, 5, and then 6. Negative 1 is no longer, negative numbers are no longer part of these positive integers. And 0 is also not part. So we have 1, 2, 3, 4, 5, and then 6. So I hope you learned something in this video. Next time, we're going to discuss about the relations about sets, the language of set. Thank you very much, and then God bless.